Hello, Assalamu alaikum everyone. This is Rida from Dice Analytics. I would like to extend a very warm welcome to all of you on behalf of Dice Analytics for today's webinar on career transition into data science. We are very glad to have two highly experienced professionals as our guest speakers today. Our first speaker, Mr. Asad Abbas, is a chemical engineer turned MBA who leverages the learnings from both in his day-to-day work. He's currently working as a growth hacking lead at Telenor. He has keen interests in growth marketing and consumer insights, employing analytical techniques and MarTech platforms to get results. Our second speaker, Mr. Hassan Aftab Mughal, is a lead data scientist and is currently working as manager contextual marketing in telecom industry. He has 6+ years of working experience in top telecom and fintech companies. Hassan had pivotal role in delivering crucial business solutions and completed several data science certifications to upskill his knowledge in his domain. He has accomplished associate's degree in AI and machine learning from Udacity and many other certifications from LinkedIn Learning platform. In today's session, our speakers will be discussing the fundamentals of data science, what to expect in this domain, the examples of a few data science applications, and effective ways to learn data science. They will also be telling about how to start a career in data science with coding or without coding, and then linking data science with the DICE analytics trainings and workshops. Also, this webinar will be followed by a Q&A session at the end, so you all are requested to kindly note down your questions during the session. That's all from my side. Thank you. Over to the guest speakers now.
Assalamualaikum everyone.
Walaikum salam.
Hello everyone. Is my screen visible?
Yes, it's visible.
We'll just start in a minute.
So before we start, I have a question for you guys. How many of you are actually working in data science domain? If you are, just raise your hand so I can see. So it seems like only two guys are working as a data scientist. Okay, that's fine. And how many of you are actually interested to switch your career from whatever you're working right now to data science? Okay. Still, only few of you want to switch your career. So what about the rest? Okay. So Asad, if you're ready to start, we can.
Right. Okay. So today, in this webinar, we are going to be talking about data science in general. What is the basic concept of data science, the life cycle of any data science problem, a few examples in terms of real life applications of data science, and then we are going to talk about how we can take a step-by-step journey towards learning data science in terms of both in technical domain and as well as non-technical domain. And we are going to conclude this session by a Q&A session, which is going to be about all of these questions. So firstly, I would just like to ask you guys a question. What do you think, what exactly is data science? You guys could maybe unmute your mic or just type in the chat box, whatever works for you. Right, playing with data to get insights and make informed decisions. Okay, uh, getting meaningful information from data analytics. Okay, data insights. Right, so we have multiple definitions, right? So we are just going to briefly discuss the overall concept. Data science in itself, um, it's a multidisciplinary domain. Um, it involves computer science, information technology, the academic perspective in terms of mathematics and statistics, followed by a domain or your business knowledge that you're currently working in. So in terms of this domain, there are multiple subdomains as well. If we could see from this slide, there is software development, which includes business knowledge as well as computer science and IT. Then there's another domain, which is machine learning, which involves mathematics and stats as well as computer science and IT. Then there's another domain, which is traditional research, which again includes your domain knowledge as well as the academic perspective, which is mathematics and statistics. And now, as this Venn diagram portrays, the combination of all of these domains formulates the domain of data science. So, for a data scientist, one needs to be able to have a strong understanding of the domain or the business knowledge. For example, an individual could be working in telecommunications industry, or someone could be working in banking, or someone could be working in engineering, and so forth. But the skill set that we need to have to apply data science concepts uh, are multiple. We need to have a understanding of tools, the enablers on which we can apply data science, then the theoretical, the academic concepts, which is mathematics and statistics, how do the algorithms work, and again, domain and business knowledge, which is the integral part of this entire domain. So next, we are going to discuss the data science lifecycle. Every problem that we cater for in this domain uh, triggers with or initiates with a business question. That question could be of any type, like as an HR professional, I would like to reduce employee attrition, or if I am working in a telco or an e-commerce platform or a banking, I would uh, prefer to reduce my churn, the customer churn. So these are different kinds of business questions. For someone working in the health industry, they would ideally would want to predict multiple diseases, for example, or for example, they would want to predict cancer from customers' historic visits to the clinic or whatever their reports were. So these are all types of different business questions that we are trying to answer. Without a business question, it is not really recommended to jump into this life cycle, because then we would be working in multiple dimensions that we would not be able to converge to a singular point that we are trying to answer basically. So after we have defined a business person, then we move towards exploration, which is the second step. In exploration part, what we are looking for is all of the data points that we have to address a particular question. For example, I would like to predict customer churn. So for me to be able to predict the customer churn, I need to have some data points, their historic visits, whatever their purchase history has been with our business, or since how long they have been dormant, or what was their last action, and then and so forth. So there are multiple data points that we have. So these data points in actual help us to understand, as well as help us to answer the business question that initiated this life cycle basically. So once we have uh, understood the data points, once we have a proper understanding of whatever the data points we have at hand, be it in terms of POS machines or in our company's data warehouse and so forth, let's assume we have 100 data points. So, but all of those 100 data points are not going to be helpful in answering this particular business question that we have selected for now. So we are going to select a certain number of data points uh, to proceed with our analysis. For example, total 100 data points. So we have selected 60 or let's say 70 data points. So in ingestion and ETL, we are only going to take forward those 70 data points that are specifically needed for this data science problem, and we are going to ingest it in our system so we can start working on these. Uh, then there's another concept which is feature engineering. For example, we have 70 data points in 3 different features. So we want to be able to enrich our data science model with more information. So we are going to create more features or more variables from those 3 features that we had decided to ingest from our explore section. So all of that part goes into this ingest and ETL part. Then the next part is the wrangling and the visualization part. In wrangling, we are identifying the problems that we might have in our data set. For example, there could be missing values, there could be some outliers, or there could be abnormal values which we would ideally want to address or discard or whatever uh, is feasible in terms of our business understanding. Side by side, we are also visualizing our data. For example, if we visualize our data points on a scatter plot, we are able to identify our, you could say, the outliers, or we could uh, create a box plot which would help us identify the outliers. So that wrangling and visualization part goes hand in hand. So once this part is done, then we move towards the second major step, which is primarily the AI part. Uh, this step also includes 5 different steps. First of one is the choosing part. In this part, we choose a specific algorithm that we understand is going to best answer our business question, or is going to best address our business problem that we are trying through this domain. Once we have selected a machine learning model, then we build or train that machine learning model. For example, we have selected a classification algorithm decision trees, let's say. So afterwards, we are going to train that algorithm based on our data points. So the model now understands what are the patterns or what are the hidden insights that exist in the data set that we have provided. So once that model has trained on that data, then we are going to validate that. Now, how are we going to validate our model? We train our model. Let's assume we have at this point, I would just say for the ease of example, 100 data points. 70 data points, we have trained this model, but on 30 data points, we kept them out. We didn't train our model on those 30 data points. So on those 30 data points, I'm going to then validate my model. Like, has my model learned the uh, predefined patterns in the data from that 70 data points, which can answer the hidden patterns in the remaining 30 data points as well. So this is kind of a partitioning and training and testing of our machine learning model. So once we are pretty certain that our model is working perfectly and we have like gotten some good scores, then we can move towards deployment. This is the real-time application of our machine learning model that we have trained. This could be uh, on the back end of on a mobile application or a website or some recommendation engine or any kind of application that you might have. So that is the deployment part. Now, once we have deployed the model, then the next step is the testing part. So initially we had 100 data points that we had in our hand. We trained our model on 70 data points, and then we validated that model on the remaining 30 data points. But in terms of real life application, once we have deployed that model, then there are going to be more like new unseen data points. Those are going to be generated in real time. So our machine learning model is required to predict perfectly based on these new data points. So this is the testing part. If at any particular point our machine learning model starts to give poor scores or poor recommendations, then we take it back to the choosing part. We then further analyze, is our machine learning algorithm that we had decided earlier still the right choice for this problem? Should we maybe choose a different algorithm which could have a better accuracy in terms of testing environment and so forth? So this is an iterative process, be it through the validation part or be it through the testing and choosing part. Most of the steps that we do in data science across the data science lifecycle, except for the business question part, are iterative in nature. Then there's the third part, which is one of the most important aspects of this domain, and that is storytelling. Once we have worked on all of these steps to answer this business question, then we need to be able to communicate our findings, communicate whatever we have done to the senior management, to the highest decision makers in the company. So we can basically convince them to rely on this model, to rely on this domain, and give us a go ahead to put this in place for real time analysis. But there's a catch here. If we talk to our CXOs in terms of the technical parts like machine learning models, what were the evaluation metrics, what were the deployment platforms or architectures, or whatever were the ingestion or ETL techniques and all of that technical part, it is not going to make uh, great sense for those uh, business minded people, for those individuals who belong to the commercial domain. So what we need to be able to do is we must be able to convey our findings, convey the flexibility and the utility of our decision sciences model in terms of ROI. Like, what is this model going to give in return in terms of business? Is it going to bring in more revenue, retain more customers, and all of that? So we need to be able to quantify our findings to the senior management in terms of business KPIs. That is the key aspect. If we are not able to do that, regardless of our efficiency of the model, they are not going to believe, or they are not going to buy into our idea of data sciences. So there are here are a few examples of whatever includes in question, in exploration, ingestion, and so forth. So in question, it could be prediction of a patient's health. It could be prediction of a loan defaulter, or it could be for an assessment of a launch of a new product. Then in terms of exploration, we need to analyze, we need to explore whatever the available data points are. There could be patient reports, their historic visits, customer's history with the platform, or historic credit of a customer at a bank, let's say. The next part is the collection of data. In this, as we previously discussed, in the ingestion in ETL, we transform our data and we create new features from the existing dataset that we have to enrich information for our machine learning model. And then followed by data understanding in terms of missing values, in terms of feature shortlisting, visualization of data and outlier handling, just as we discussed through box plots or through scatter plots and so forth. Then there's the AI part. We are going to discuss this AI part again with an example of unknown technical example, let's say. We have a law enforcement training agency. So here's our soldier number one, which is one of the iterations. This soldier was trained in this academy, and he or she passed out from that academy with flying colors, let's assume. And then that soldier was deployed, and the crimes were reduced. For example, they were deployed at a security checkpost, and they started to figure out whatever the techniques were from those who were involved in crimes, and they started to reduce. But as the time progressed, the crime started to increase again. Now, in another example, we have soldier, which is soldier number two. That soldier was trained in that same academy, passed out from that academy with same grades, and he or she was also deployed at a checkpost, and crimes also reduced. But contrary to soldier number one, in this case, the crimes reduce permanently. So if we are to relate this example with this life cycle, we have chosen a soldier, and then we have built or trained a soldier in an academy. In this case, soldier could be a machine learning algorithm, followed by validation, which is the basic test that we conducted from that soldier, and then followed by deployment, which is the deployment of a soldier or an algorithm at a checkpost. Then this is the testing part. Now, in terms of testing, if soldier is still able to reduce the crime, which is the soldier number two case, then we can stick to this soldier at that particular checkpost. But if in case crimes start to increase again, then this testing part is failing again. So what we are going to do is we are going to bring this soldier back to the academy. We are going to give them more information. Either we are going to deploy them at a different checkpost, or we are going to train them with new data points or new criminal activities or new criminal techniques, and then we are going to deploy that soldier or that model at the checkpost again. So this example kind of replicates what this AI lifecycle basically is in terms of choosing, in terms of training, in terms of validation, in terms of deployment at a checkpost, or in terms of deployment at a application, and then followed by testing in real life, which could be at a checkpost or which could be at a website or a mobile application. Any questions so far? I can see a raised hand. If you could please share your question. So, okay. Right. So in this example, what we are going to do is we are going to stick to soldier number two because he or she has successfully reduced the crimes permanently. And we are going to discard soldier number one. Not necessarily discard, we are going to retrain or deploy that soldier at a different checkpost. So again, the solution here is the soldier must be sent back to training academy to retrain himself for changing tactics of the criminal at that particular checkpost. Right. So what we have seen so far is the data science life cycle, how from the initiation of a problem statement for a business question, we move step by step in order to answer that, and we end up at a storytelling part. So in terms of our daily activities, we are making hundreds of decisions from like waking up, getting out from the bed, or getting to the breakfast table, and then going to the office and so forth. All of these are multiple decisions that we are taking every day, and we have to take the right decision as well. If we are taking wrong decisions, then we are going to suffer in terms of our productivity for the day. Similarly, the organizations are doing the same. They have to make decisions. They have to make hundreds of decisions. Some are of minor scale. Some of them are on a really large scale. So that is something that business organizations are doing every day. So next up, in terms of decision, what helps us make our decisions basically? There are different components. First of one is the information. This is the entire pool of information that we have, the entire pool of data points that we have. Now, based on our knowledge, we are able to connect these data points. Like if this data point connects with this one or this one or this one, so that formulates the knowledge part. Now, this is the entire connectivity of our data points that we had in our data warehouse, or in terms of in our memory, and it formulates the knowledge and the entirety of knowledge. Now, based on that knowledge, we are able to, you could say, shortlist this path based on our experience. For instance, initially, based on our knowledge, we took 3 to 4 different multiple strategies. One of them worked perfectly. So that strategy is so that strategy now formulates the connection of these specific data points, because this is something that we are now experienced. Now, based on this experience, what we can identify is, based on those 4 to 5 different experiences that we have now shortlisted one of those experiences which directly had an impact in terms of increase in revenue or reduction in churn or whatever the business problem is. So that formulates the strategy. We are able to take a direct path in terms of catering to this noise that we had initially. We are now taking a direct path to our end objective. Now, we could you could say eradicate even further data points, but that would be on our intuition, not in terms of strategy and not in terms of experience. Like, we are not 100% certain that the 3 data points that we have skipped here were those integral in terms of reaching to these data points, or were these not relevant but we were still taking them anyway. So if without these 3 data points we are able to get to this objective, then our intuition has worked perfectly, and we have removed the time constant or the resources constants that we have in terms of these 3 data points. But there's a possibility that it could may not work. So then we can conclude that these 3 data points are integral for us to get to these data points. Without these, we cannot get there. So there's a different combination, different collaborative environments that we have in business organizations to get to an end objective. All of this information, knowledge, experience that we have, previously all of this was in terms of human memory, whatever the human capacity was, but this has in current times changed drastically. All of this information, knowledge, experience now exists in terms of data points. uh, let's say in terms of holiday season, we had an increase in revenue. Now, this is something that we know in terms of our human brain capacity, but we do not know the entire or exact correlation between all of those data points that help our revenues to increase in those uh, holiday period. So that is something that is entirely in existing now in the form of data. But data could have multiple or different interpretations. For example, if we have multiple team members, if we have a team of 4 individuals, all 4 of them are going to have different pieces of information, different interconnectivity of those data points in terms of knowledge, different experiences. Like, one of those individuals could have previously worked in a telco industry and is now working at an e-commerce platform. Another one could have a background in banking industry. So all of those are going to have different knowledge, different experience, and different strategy points. But based on the data that we have about this particular e-commerce platform, and based on the correct interpretation of those data points, all of all these 4 individuals can formulate a strategy which is in actual going to increase the business KPIs of that particular e-commerce platform. So these things vary, these things change or evolve over time, but that is one of the key elements as a in this data science domain that we need to be wary of. So next is the blend of experience and data. Now, in terms of okay, so I will just give an example. Let's assume that last year, in second week of April, we had uh, abnormally high amount of rainfall in our city. So if I'm using my data points to project or to forecast numbers for the second week of April for this year, my model or the data points are going to forecast lower sales. But what we know is that, based on our experience, that the reduction in our KPIs was due to rainfall, which is not projected this year, which is not forecasted this year. But this is something that is unknown to our data, as long as we have not provided the weather information or the future forecast of the weather. So this is something that is unknown to data. So this is where the human capacity then comes in. we need to have our brain and our heart right into this data points as a combination to make sense of all of this. If we are entirely relying on data points, then we are going to have some problems in terms of projections, in terms of forecast, because in terms of data points, the experiences or the customer behaviors can change. For example, an e-commerce platform had a really poorly designed website last year, but this year they have worked on customer experience. They have a perfectly designed and perfectly efficient customer journey enabled website as well as a mobile uh, platform. So now they are going to be able to generate more sales from their online platforms, which did not exist previously. So what in terms of data points, we are still going to get poor sales from our online platforms, but what we know is that now we have changed our platform architecture and we have improved. So that is something that we need to be able to then indulge with our data to change those forecasts or tweak those forecasts. So, which could involve reality, emotions, intuition, creative thinking, and all of that. So to do all of these uh, analysis in you could say in our data warehouse, which has millions of data points, that is something that is not possible to be done directly through our human brain. We need an enabler for our human brain to be able to do all these kinds of analysis. Here's an example. I'll just give you 10 to 15 seconds. You have to count the total number of nines in this image. You could just chat the number of nines that you see from this image. Right, so the first answer is 6. Next is again 6. Any other inputs? Okay, so as input is 13, as is 9, then 7, 5. So we have about 9 to 10 or 8 to 10 inputs. What we can observe directly from these inputs is that like we have inputs 5, 6, 9, 7, 13, 9, so forth. What we can be certain from these inputs is that there exists an error because everyone is contributing with different count of nines here. But if we enable our brain uh, with the color, then we are able to count the number of nines. Now you have again 10 seconds and you have to count the correct number of nines in this image. You can type that in the chat box. Right. So what we can see from this example is before this enabler, multiple participants got the answers wrong and they took a comparatively higher amount of time to answer that. But in terms of this enablement, we are able to answer with more accuracy and we are able to answer uh, in lesser amount of time. So that this is something that is essential for our brain to like make sense of numbers, make different strategies, and so forth, because we need enablement uh, to basically solve all of these problems. So what we have now is data. Then we have a team. All of this includes information, knowledge, experience, strategy, intuition. Then we add another combination to this, which is a tool or visualization tool, uh, let's say. So this is an example of a visualization dashboard. So if we are to look into this dashboard, we can in terms of data points, raw data points, we would probably have hundreds or thousands or more data points in terms of raw data. But in terms of this data visualization, we are able to uh, we can basically make sense of the data readily in terms of these charts, in terms of these trends. Something is going up and something is going down, and so forth. So this is the enablement that we get if we use another tool. It could be for data analysis, it could be for data visualization, and so forth. Okay, so next, let's just explore a few examples of data science and data generation. First example is of data generation. So in 60 seconds, in for every 60 seconds, there are 400 hours of videos uploaded on YouTube. Um, then there's almost around 0.7 million hours of videos watched. If we are to look at a different platform, let's say Instagram, so there are more than 65,000 posts uploaded every 60 seconds. In terms of Snapchat, there are 0.21 million snaps uploaded every 60 seconds. So what we can see from here is the amount of data being generated is immense, which in return enables us to dive into data analytics domains, because we are going to be able to make use of all of these extensively available data points. Right. So I have a question from every one of you. You can just look at these different images, identify what's wrong with these images, if there is any. Right. So first response is can't see any problem. Okay. Anyone else? Time change disorder. Okay, so like time change, background, no looking shade, these are just the aspects of these images. Like this is something that is not wrong. Like if I were to take a picture of myself, I could be looking anywhere. That image would not be wrong, or I could change backgrounds of my image. It would still be a perfectly fine image. Right. So there's nothing specifically wrong in these images. Like this is a child, let's say 4 to 5 years old. This is someone maybe in late 20s, or this is someone is in 40s maybe. So what's common in all of these three images is that none of these people exist in real world. All of these faces, these are not real people. As Hassan has also provided a link on the chat box, there's a website called This X Does Not Exist, and there you could click on a person. And what we can conclude from this is, like, this is an application of a data science platform. You can generate through a machine learning model. So for a common man, if we are to look at these images, we are not going to be able to find anything wrong with these images. But in actual, these faces have never existed uh, on Earth. These are just randomly created images, which we can like you could never identify anyone else with these uh, faces. Then the next example is, how do self-driving cars see? So, for example, a car is driving on the road. How is it able to uh, make sense of whatever is surrounding that particular car at any particular moment? So, what it does is it identifies everything that is in its vicinity as a data point, and then it tries to predict: is it a car, is it a person, is it a stone, or is the road ending, is the traffic light red, green, or yellow. So this is something. This is how the cars work. For example, if you look at any of these particular scoring that we have, if we are further away from this car, the percentage is 50, around 50%. But as we move near to this car, the percentage increases from 60, 70% to 90, 93%. So this is something. This is how the self-driving cars are predicting whatever is surrounding them, and are they supposed to stop the car? Are they okay to go with the current speed? Do they have to stop in terms of zebra crossing or in terms of a red signal and so forth? So all of these are being identified as different data points. Then there's another example of Spotify. What Spotify does is it analyzes every kind of data point that we are generating in terms of the music that we are playing, the time of the music, like what time of the day that we are playing the music in, what time of the day that we choose to play music on a louder volume or a lower volume, which kind of music or which types of songs that we play on a higher volume or a lower volume. What do we share with everyone else? What do we skip every time, or what do we keep listening time and time again? For like, if I am listening to a song X, what are the other people who also listen to the song X were interested in listening to? So those are the recommendations that I am going to get based on behaviors of the other listeners on their platform. So there are hundreds of thousands of data points that are being analyzed at every action that we do on the platform, and to improve the suggestions or the recommendations of the music that we get on the platform. Then there's another example, image captioning. We just provide uh, images to the machine learning algorithms, and they identify in terms of descriptive form whatever the character is doing in that particular image. For example, we provided this image. The machine learning algorithm predicted that the man in black shirt is playing guitar. In the second image, the construction worker in orange safety vest is working on the road. So these two are perfectly fine. Here it says two young girls are playing with the Lego toy, but in terms of age, only one of them is young. The other one appears to be someone who is in our 20s or 30s. So there is a chance of error that uh, our machine learning models may answer with. So this is something that is dependent on us, how we are interpreting our uh, recommendations or the predictions that the machine learning algorithm has given to us. So we are able to see if these are correct or not correct. Then there's another basic example of Google Translate, which is considered to be a very essential application in tourism industry, because if I am traveling from Pakistan to, let's say, a Central Asian country which has a different national language, then I am not going to be able to understand whatever the signboard says or whatever it says on the airport and so forth. So I'm going to make use of this application then. Another example is of cancer prediction. This is an extensive application in health industry. We just provide customer records or the customer tests that we conduct through different machines, and we give all of those tests as an input to our machine learning models, and our machine learning model does all of the analysis that the machine learning algorithm is supposed to conduct, and then it recommends if the patient has cancer or any other disease, for the example, or if he or she does not have. So that is something that is really important in terms of timely identification of severe diseases. So once we are done with examples, the next step is how can we enable ourselves to learn data science. Again, this is something that is subjective to every individual, how one wants to proceed with learning or with their career or with their domain, but there are few standardized approaches that we have, and we are going to follow that. So the first thing that we are going to do basically to learn data science or to learn any new thing is basically going on Google. We could just type in how to learn data science or different data science algorithms or tools and so forth. But what we are going to get in return is a cluttered environment. We are going to get multiple results, including multiple platforms, multiple domains, multiple libraries, and so forth. So, as a beginner, if I'm starting from scratch, I'm not going to know what exactly is neural network or what exactly is deep learning or what exactly is TensorFlow, Pandas, NumPy, and so forth. We need a step-by-step approach to be able to make sense of all of these techniques or all of these terms for us to be able to uh, like step by step build on our expertise in this domain. So it's a basic three-step process. In step number one, what one needs to have is uh, usability knowledge of a tool, a no-code tool, or a programming language for data manipulation on what we are going to basically collect data on, transform our data, do feature engineering, data visualization, and so forth. So once we have expertise on that, then we can move towards the second step, which is the understanding and learning of algorithms, mathematics, and statistics. All of those machine learning algorithms that we have work on, in background, work on different statistical techniques, which are, again, there are multiple formulas in terms of what we could have probably studied in college or in university, which include calculus, numerical methods, and so forth. So all of these techniques involve such uh, academic knowledge at the back end. So the next step is to learn all of these techniques. Then the final step, which is the business knowledge, domain knowledge or business understanding. So for some people, this could be a starting point, which is the ending point here. For example, if I have worked in marketing industry for 10 years, then I have the required business understanding and the domain knowledge in which I'm going to be applying these data science techniques. So what I need now is the tool or a language, followed by the understanding of algorithms. For someone who is a fresh graduate from college or university, they do not possess this business understanding or domain knowledge that is essentially required in the industry. So what they can begin with is a tool or understanding of a language for data manipulation. Then they can work on understanding of different algorithms and statistical techniques. And as the time progresses, they can develop the understanding of the business or the domain that they are working in. So once the combination of all three different steps is met, then the end objective of applying data science techniques to um, address a business problem can be achieved. So there another problem that people usually encounter in this while they are thinking of stepping into this domain is the difference in IT and non-IT background. So this is something. This is a Venn diagram that we discussed at the very beginning. So in if we compare IT people and non-IT people, mathematics and statistics, for example, someone who has done a business degree in, let's say, majored in marketing or sales, they are not going to essentially know in detail about mathematics and stats. Similarly, for IT guys, they are not going to be familiar with this domain either. Then there's business knowledge. For those individuals which have uh, business knowledge, which take who uh, on daily basis take business driven decisions. Let's say, what is the campaign that we need to devise to reduce churn, to revive our customers, or to increase our revenue and so forth. So non-IT people who have a business background are going to have a functional knowledge of this their domain, but IT people are essentially not going to have this domain knowledge uh, in comparative expertise to these non-IT people. Then there's computer and IT. IT guys are going to have their expertise in this domain and different infrastructure and different techniques that are used in the industry. But non-IT people who have business background, they are not going to be hands-on with these techniques which are or platforms which involve computer and IT. So to begin with, there is one domain that IT people have the expertise in. Then there's another domain which have expertise of business people. Then there's another domain which neither them has. So the starting point for a learning aspect of this domain is pretty much even. So then there's this question: how many of you have used Microsoft Excel? I'll just answer this question myself because everyone has used uh, Microsoft Excel in their life, be it marketing, sales, IT, health, and so forth. But there are a few, you could say, limitations of Excel. One primary limitation for Excel is uh, the capability or the capacity of data handling. We know for sure that Excel cannot go beyond 1 million records in one single file. But if we are using some different tools, we are able to uh, manipulate data or ingest data in GBs or terabytes of data. So that is something that Excel lacks. Then there's another aspect which is of the predictive modeling, which Excel does not have. But in these tools, there are advancements, and we can apply such techniques to move forward with. Next up are the different tools for techies. Um, for those who are from IT background, they can have exposure in Jupyter Notebook, PyTorch, TensorFlow, Apache Spark, and so forth. But these are all that are backed by coding. So for someone like me who does not necessarily like to code all day or even partially, for me to be able to get into this domain could get, you could say, hectic or frustrating because I do not have interest in this particular field. But this is something that has been addressed in recent years. So we have moved beyond programming now. So in terms of hesitation of stepping into this domain, like having a working knowledge of different programming languages, which include Python, VB, C++, Java, and so forth, we do not necessarily have to have these working expertise of these programming languages to be able to work into this to work in this domain. So similarly, just as we have Python and R, we have other no-code platforms which can address the limitations that we had in Microsoft Excel. Um, there are different examples of these tools. For example, Rapidminer, SAS Enterprise Miner, NIME, IBM Watson Studio, and so forth. One common thing that we can uh, have a clear understanding from this image is that most of them work in a similar manner. Here we can see a workflow of combining of different groups or different nodes or different operators. Here we can again see a workflow, different nodes or groups that we have. In NIME, again, we can see something similar. And again, in IBM Watson Studio, we can see something similar again as well. So the point being, if you are able to get hands on at least one of these tools, you are then enabled to, you could say, have a functional knowledge of how no-code tools work. You can then work on different tools, IBM Watson Studio, Rapidminer, and so forth. So that is essentially a part or a pathway for non-technical people. Right. So this is a workflow. This was created on this tool, a NIME Analytics platform. What this workflow is doing is it is analyzing the data, raw data, pre-processing, training of an algorithm, doing EDA, data wrangling, and all of that. Then it is creating clusters. This is a customer segmentation business problem that is being answered, and combination of these handful of nodes or groups or operators are an alternative to hundreds of lines of codes that we might have to have uh, like write on Python or any other programming language that we have. So this is an alternative to those languages for those who are not interested in like essentially learning in programming languages. But if someone wants to learn programming languages, then they can just discard these tools and move directly towards the languages part. So in terms of again IT people and non-IT people, non-IT people can initially rely on a no-code platform, which is Nime or Rapidminer and or other platform. Or for IT people who have a degree in, let's say, software engineering or computer science or computer engineering and so forth, or someone who has learned these programming languages, they can just uh, learn data science algorithms and increase their domain knowledge with time and start answering business problems. So this is one study that was conducted a couple of years back, which stated that data science is a must-to-have skill set on your resume, would be a must-to-have skill set on your resume by 2025. But after COVID-19, this has drastically changed, and majority of the people believe that this is something that is necessary to have on your resume by 2022, 2023, because the digitization of multiple companies, multiple platforms has uh, drastically increased. Then there's another kind of a misperception regarding this domain. That is, if someone is working in marketing, finance, sales, uh, engineering, health, and so forth, they have to uh, like pivot their entire career and then move towards data science and you could say proceed with the career of data scientist. But that is something that is not necessarily to have. This is a secondary skill set that could easily be applied in marketing, in sales, in health, in the engineering, and so forth. For example, in marketing, you could have um, churn reduction. In sales, you could uh, create a model to uh, find hidden patterns to increase your sales. In health, we have uh, previously discussed the example of cancer prediction and so forth. So this is something that is essentially a secondary skill set to have, not necessarily a change in career. So in terms of primary skill sets, you could have marketing, finance, HR, sales, IT. But in secondary skill set, now this is data science. If you go back 5 to 10 years, at least in Pakistan, the secondary skill set that was most to have 10 to 15 years ago was Microsoft Excel. Then that changed from Microsoft Excel to SQL. Now this has changed to data science. So this is something that is a secondary skill set which would enable you to proceed with your primary skill uh, with higher efficiency. Right. So the next part is how we can proceed with our career in data science with and without coding. So we have discussed the life cycle. We have discussed the examples of the applications that we can expect in this domain that we might or might not want to work on. And then we have also discussed what is a primary skill set and what is a secondary skill set. And to, you could say, to enable ourselves further in our primary skill set, we would want to ideally develop a secondary skill set, which is the data science domain. And we have also discussed that we could either do it that with coding, Python, R, and so forth, or we could do that without coding using no-code platforms, which are Nime Analytics platform, Rapidminer, SAS Enterprise Miner, and so forth. So what DICE offers is it offers courses for both of these domains. I'll just run to the website. If you go if you visit diceanalytics.pk, you can just go towards training, and here you could find a list of trainings. First one is data science and ML, then there's advanced machine learning, then there's data science for non-coders. So if I just click on data science for non-coders, let's say, so what you can find here is the instructors that are going to be teaching the course. the intervals of the course, and what in great detail that you are able to see in this is the course outline, which is the most important part. Here you can see week-wise segregation of the entire course. What are the exact topics that you are going to cover in this course throughout? It's an 8 weeks course with applied use cases and so forth. So in terms of decision making, we have decision trees, random forests, association rules, recommendation engines, and so forth. Then there's regression. Like there are multiple, the entirety of the data science lifecycle and the data science applications are covered in all of these uh, trainings. If head to the other training, which is the advanced machine learning, here you can again view the descriptive form of the course. What exactly are you going to be learning from this course? What are the skills that you are going to learn from this course? And then again, the platforms that you are going to cover in this course, and uh, the multiple examples, let's say face recognition, computer vision, disease prediction, and so forth. So all of this information is available on this course. Uh, so for you to be able to um, proceed with this career in data science, what we have observed is that coding is not a necessary part. And in as a offering of Dice Analytics, we have a we have segregated courses which are data science and non-coders. Then there's advanced machine learning, which involves applications of deep learning, and there's data science and machine learning. The reason what why we are recommended this, why we are recommended uh, like these courses are because these are a step-by-step approach from and from an entirely no code background. So you don't necessarily have to have any functional knowledge of any programming language, any no code tool, or any statistical or mathematical concepts that are essentially required in machine learning or in data sciences. So yes, I can see one question. Are we also going to be learning Rapidminer in the course? Yes. So the course that is primarily about data science for non-coders, that course primarily uh, is based on NIME Analytics platform, which is pretty much similar to Rapidminer, but we do dedicate a certain amount of lectures to Rapidminer as well to replicate whatever we have done on NIME Analytics on Rapidminer. So you are able to get an exposure of two different tools. So once you have an exposure of two different tools, then you can just uh, proceed with the tool of your choice, or if you would want to select a different uh, platform, let's say SaaS Enterprise Miner and so forth. And one additional important aspect of taking a course with DICE is that we have a really strong alumni network across the industry in telco, banking, and so forth. And we do recommend our participants, high performing participants, to all of those uh, industrial alumni. And all of these courses are taught uh, by instructors which are essentially uh, working in this domain for years. So they have a functional knowledge and daily understanding and daily application of decision sciences uh, in real life. So this was the content of the webinar. We have dedicated the last section of this webinar purely for Q&A. If you guys have any, you could just ask over the chat box or on mic.
So I think we can go over the questions one by one. So there's a one coming from Nizakat Ali that's saying if there is any kind of research that which course is beneficial for you. So in terms of data points, if you ask, so both courses have its own pivotal role in the industry. There are certain people coming from non-IT background are actually getting benefits, and they're applying the knowledge that they're getting from the course to the current industry that they're working in. So similarly, for the people coming from the IT background are also getting benefit, and they're kind of transitioning from the current role to the data science role. So it's up to you. It's your choice to actually figure out which is best for you. If you are the person who is actually interested in the coding part, so then you have to like get your hands dirty in the coding. If you're not that kind of person, if you are more to actually learn the data science and just apply it, so without getting too much or without getting into the learning of the coding platforms, then I think the course that's for non-coder is suitable for you. So in terms of how many projects we're going to cover, each for every week apart, I think for initial 2 weeks. After that we have a project coming in every week, so approximately 4 to 5 projects coming in every course, even if it's for non-IT or for IT backgrounds. Approximately 4 to 5 projects, and all projects are different in terms of domains, in terms of practical implementations. Okay. Can can you guys unmute yourself as well, or it's only that you can write in the chat box? Okay, it seems like you can only write in the chat box, you cannot unmute yourself. Okay. So I'll be taking questions one by one, and Asad is also going to help you out in whatever directions that you're looking into. So Daniel is saying that okay, so Daniel is again asking the same question, if which course is better for you. So for that, you have to go to the website, see into the course content, see if it is aligned to whatever you are trying to learn, and see if it is aligned with your current domain and whatever the objective that you have. If you are actually into transitioning from whatever the current domain to the data science domain, with programming or without programming, it's up to you, right? So you have to take the decision by yourself. And yes, it's for 2 months. How to improve analytical abilities for handling data? Practice, practice, and practice. So Majida, if I think of my overall transition for the last few years, it's not a one-day process. It's not something you get over the night. Day by day, you actually start learning with your mistakes, and you start learning with whatever knowledge that you get. Sorry. It's a you can say it's a transition that happens intuitively, and it happens iteratively, not going to happen in a one day. So if you ask how to improve your analytical abilities, just work and practice, and start looking to tools, start looking to the certain examples given by the people over the internet, and try to address some questions, try to figure out what could be the possible answers, what could be the possible ways to solve that kind of question, and then definitely you're going to find a way to actually drive insights and find relevant solutions for your problems. Asad, how you want to take these questions, because I think there's so many questions coming in, and maybe we can address few of them, or What do you think?
I guess we can just read through the questions and then give a comprehensive answer once we nearing the end of time. In terms of this analytical abilities for handling data, again, the sole correct answer of this would be practice. In terms of practice, what you could do is you could find different problems that you might face or you might have the data for in at your current workplace. If that is not the case, then you could just go to um, online platforms such as Kaggle, Google Datasets, and so forth. There you could get real life datasets with problems that are required to be solved through those datasets. Then you can just try to solve the that particular problem from your uh, like whatever you do with that data set basically. So that is something you are going to enhance step by step. You could, I'm not exactly sure what is your current level of expertise, but if you are from a different domain, that you could initially begin with Microsoft Excel in terms of pivoting, group bys, and so forth. Once that is done, then you could move towards a tool or Python or anything that you prefer. And this that is how you are going to be able to define your abilities.
Uh, right. Uzair is actually pointing out that he was one of the top performers in MS SQL training, and he's still looking forward to get a job in terms of data analytics that he has been doing. So, Uzair, are you following the job portal that Dice is offering? If you're not following it, then please go ahead and try to apply for the jobs that are offered in the on the portal. And yeah, if you're applying for it, then just wait and see if you get an interview chance, then you're definitely going to have your placement. Okay, so Shiraz is asking, can you explain different in business analytics course and data science course? If I'm not from IT background, digital marketing with options of moving into growth marketing and product management. Okay. Asad, do you want to take this one?
Right.
So the
Okay.
person is, yeah.
Right. Yes. Okay. So from non-IT background, digital marketing with no options of moving into growth marketing or with options of moving into growth marketing.
So the person is asking if so the person is saying that
Right.
yeah.
Yes. So in terms of moving towards this domain, like I am a chemical engineer in terms of educational background, so I am from an entirely different space. But this is something that one needs to, like you could say, improve with time. What you could do to improve is you could. There are two different pathways that you have to take simultaneously in terms of digital marketing and growth marketing, so forth. One is you could start learning a tool uh, on which you are able to analyze complex data sets. On the other side, what you could do is you could get a thorough understanding of your domain. Digital marketing, what are the core KPIs, what are the major platforms, what are the data points that are integral in terms of this domain. For example, in terms of growth marketing, so I'm currently working as Telnor as growth hacking lead for the digital science and Micron app. So my job description revolves around all of this in terms of uh, getting acquisitions, in terms of getting revenue by uh, like you could say proposing different products that we have. So all of that has to be done through insights which are to be extracted from data. So that acumen of data analytics is essential to be, you could say, to succeed in any particular domain of this side. So in terms of non-IT background, if you do not have a background in SQL or in terms of or Python or anything, so you cannot query into data warehouse and all of that. So an alternative to that is then these tools, NIM analytics platforms, and Rapidminer and so forth. You can just ingest all of your data into this tool. Then you can create different views again, the reason for a thorough understanding of the KPIs of any particular domain is because once you are going to be analyzing the data and trying to extract insights from the data, you are going to be able to doing, yeah, essentially you are going to do that to increase the business KPI. So if you are not entirely familiar with the KPIs, then you are not going to be able to do that data analysis in the right dimension. That is something that it goes side by side, but what essentially is important is the entirety of your domain. What is the problem and from where does it initiates from, and what is the end objective, and what could be the what could be the solution to that problem basically. So if in terms of digital marketing, you have to reduce your cost per install CPI, which is one of the key metrics, or effective CPI. So you have run multiple campaigns on Google Ads and so forth. So that all of that is going to generate a lot of data. So then you are going to analyze all of that data, and then you are going to find what gives better CPI. But also you could find something like a particular campaign gave a really poor CPI, but the reason for that poor CPI was one or two critical factors. If you remove those factors which were hampering the CPI, then you can just skyrocket your or as that opposite, skyrocket your installs or reduce your CPI. So that is something that are, again, that is the key element of this particular domain, of finding hidden patterns that are not essentially visible to us uh, visually.
Thank you, Asad, for adding so many examples. So there is another question that's coming in that someone wants to ask that if there are any kind of tips while studying data science, and what is the best application you recommend in the learning process. So, well, if you ask about me about the tips of learning data science, I would definitely ask you to make a track of whatever you're learning and try to revise your key concepts, try to fix the basics, try to understand the core objective of any algorithm that you're studying, and try to understand the key parameters, the hyperparameters that exposed to you in any kind of algorithm, and try to learn it as a tool. So uh, this is not definitive, or it's not defined anywhere that you are going to apply random forest or you're going to apply k-means on any problem or any defined problem. uh, these are all just tools available to you to solve a problem. So whenever you're given with a question and you are tasked to actually deliver some kind of solution or some kind of positive increase in the increase of whatever metrics that you're looking into, then you need to decide whichever tool that you're going to use. So in terms of deciding the algorithm that you're going to use to solve that certain problem, you need to understand how algorithm works. And to understand how algorithm works, you need to actually go into the depth of the core objective of that algorithm, right? So while learning data science, I would only ask you to like uh, make a track of whatever you're learning and try to revise it as much as possible. That is the key thing. And then there is a question that's saying that what is the difference between data science and machine learning. So the two words, data science and then machine learning, are actually interchangeably used. Data science is actually is a bigger, I would say, circle, and machine learning is the subset of data science, and deep learning is subset of data science. Data analytics is also a subset of data science. So when someone discusses data science, that means uh, all of uh, the key things that you can do with data, and that includes statistical inference, and that includes algorithms, that includes uh, insight generation part, that includes how you're going to approach towards a problem, how you're going to create data sets, how you're going to ingest the data sets into whatever platform that you're working in. So that's all part of data science. But when you specifically talk about training an algorithm on historical data sets, or training an algorithm on using some kind of unsupervised technique, then that's something that you're trying to actually make machine learn on the data sets, and to learn on the patterns, and to do predictive analytics, or to do predictive modeling. So that's something closely related to machine learning. But when it comes to data science includes everything. So it's kind of a subset for it. I think that's satisfies. Okay, so do we have any other question? I think non-tech person needs to learn data science and develop a business in your own field. So as per the Nida's comment, so she says that a non-technology person needs to learn data science and then develop a business in your own field. That's not pretty much true, but partially true, yes. As I earlier mentioned, and as Asad also mentioned multiple times, that you need to actually look into the problem, or the question that you're trying to answer, right? Data science is actually so you're going to leverage data science techniques, you're going to leverage machine learning techniques to actually achieve something, right? It's not going to be like without having any question, without having any kind of business problem, and you've learned data science techniques, you have learned machine learning techniques, and then you're going to use them. It's not going to happen. If you have certain problem in your domain, be it engineering side, be it petroleum industry, it can be medical industry, it can be banking industry, it can be telecom industry, it can be e-commerce industry, whichever industry you're working into, you define, you actually look into problems, and then you see if that certain problem can be solved using any kind of data science technique. If you can optimize the solution, maybe you have a simple solution using some kind of rule based technique, and you want to actually optimize it, or you want to actually increase the metric that you are looking into. So maybe your metric could be revenue generated by that system, and you want to increase the revenue using data science. So that's pretty much subjective. It's not going to be pretty straightforward. So uh, so there is another question that says, highlight and elaborate the data science course you're offering. I have an IT background. So, Asad, if we can go to the data science course from the website, and I can go on on that part. So there's another question that says, MS data science is mandatory for data science jobs. Not exactly. It's more like, it's not. So if you have a live example in front of you. Asad Abbas has done its bachelor's in chemical engineering, and it has done its master's in uh, as an MBA. Asad, you've done your MBA in marketing?
Yes, marketing, yes.
Yeah, so he's a marketing graduate. He has a marketing master's and chemical graduate. So he does not have any data science masters, but he's still working as a data scientist. So that's not necessary. So if we talk about course outlines, we have 8 weeks in the data science, and each week is actually is kind of prerequisite for the next week. It starts building the concept from the basics. So it gives you an introduction to Python, introduction to how the Python object works, how the data structures work, what are the comparison operators, how statements work, what are the functions, methods, and then we go into the basics of NumPy and Pandas. We do some examples on data aggregation, how group by pivoting and melting can be done in Python. And then in week 2, if we go into the week 2, so we do discussion on the assignments, and then we discuss how data can be explored, how data can be visualized, and in that part we try to understand the different statistics measures, and then we try to understand how those measures can be visualized by using Matplotlib or Seaborn, and we try to understand how the feature engineering works, and what are the different tools available for you to do the feature engineering part. And then in the week 3, we start in the week 2 we start doing is EDA on a single data set, and then in week 3 we start applying certain data science, certain machine learning algorithms on the same data set that is being used in week 2. So we do discuss some concepts of how the supervised versus non-supervised algorithm works, and what are the life cycles, how the life cycle works, how you're going to see that what different kind of things that you need to be uh, that you need to understand, like what is train test split, what is overfitting, underfitting, how cross validation works in machine learning. Then you actually jump into the actual algorithms. So you jump into linear regression in your week 3, and then in your week 4, and so on and so forth. You get exploration of multiple algorithms. So in week 4 you try learning to logistic regression. Then you try to learn what are the different metrics for you. So precision, accuracy, recall, what are these metrics and how they are being calculated, what are the core objective of calculating these metrics, and how different kind of business problems are actually uh, get benefit from these metrics. If you are looking into the fraud management kind of challenge, or if you're looking into the cancer prediction, or if you're looking for credit scoring, or if you're looking into churn prediction, how these metrics are going to leverage the ROI of this certain segment. And then if we go to week 5, week 6, and week 7, it is going to continue on discussing the algorithms part. So in week 5, you get to discuss random forest, and then bagging and boosting techniques, and then clustering techniques. And then in week 6, we see we have clustering algorithms, which includes DB scan and hierarchical clustering. And then you get to jump into association rule mining, where you discuss a priori algorithm, and then you discuss its metrics that support confidence left. And then in week 7, and by the way, on every week, whichever concept that you're studying, you get a project to work on it. And then on week 7, you try to understand that how the social network analysis work, how the dimension reductions work, and what are the available tools for you. So PCA is one of them. Similarly, then you get to see how the deployment works on different platforms, like maybe AWS, maybe Flask. And then finally on week 8, you get to if you are qualifying, so the qualifying means that you are present in the lectures, you are submitting your assignments, you're performing in your quizzes. Then if you're eligible for the final paper, then you get to sit in the final paper. And the final paper is almost of 3 hours, and it contains of MCQs and an actual data science problem that is given to you. And it's a pretty comprehensive course. So I think I've been through all of the different parts of it. I think that's pretty much for today. So Asad, can you answer this one that says that does this data science help in with SEO?
So in terms of SEO usage, I'll be honest, I have not explored, or at least I have not worked on SEO using data science. But as far as I am familiar with the concept of SEO, there are multiple keywords, and there are multiple trends of those keywords. What goes up, what goes down, what is the ideal time for a particular keyword that essentially is to be used in a image heading or a title or the heading of the article or in header of the website and all of that. So to identify multiple keywords that are going to be essential for that for your platform, yes, you can again work on a algorithm to find hidden patterns in terms of keyword identification. For example, you could have historical data of keywords, and you could have their trajectory in terms of increase or decrease with respect to time and all of that. So you could find relations through those data points as well. So again, this is something that is essential to domain knowledge or business understanding. For someone who is an SEO expert would know what are the key KPIs that do matter in this particular domain, and they would be able to collect or prepare the relevant data for this. And then the learning of the data science domain can help with that, with those data points to make them work together and to find insight. What essentially we require is to find insights from the data we have. Once we have the data in with different features, different columns, and we have hundreds or thousands of data points, then what we are looking for is the combination or hidden patterns, like what in actual triggers a rise in a particular keyword. So that is something that data science answers.
All right. Now, if there aren't any more questions, I'd like to formally conclude the webinar. To all the attendees, we hope you enjoyed the session and learned a lot from it. Thank you for your active participation. You can email us for the recording or any queries regarding our trainings at info@diceanalytics.pk. I would also like to thank our guest speakers for giving us their precious time and sharing their valuable insights with us. Thank you so much, Mr. Asad Abbas and Mr. Hassan Aftab Mawal. We had a great time on this webinar with you.
Thank you, guys. Have a good day.
Thank you very much. Thank you.